All right, so on question 6 here, what we want to do is integrate this guy, and on initial inspection, you'll notice that it's not really going to be possible to solve this one out by making a u substitution, because if you take the derivative of the natural log, that's going to be 1 over y, and if you take derivative of y, that's just going to be 1. So on this one, we're going to have to set up integration by parts, and we're going to let u equal one thing, and we're going to let dv equal another, and then we're going to do our integration by parts. Okay. In this case, we want to let the natural log be u whenever we can, because it actually integrates pretty easily, differentiates pretty easily. So we're going to let the u equal the natural log of 5y. That means that dv is going to be y dy. So over here, du is going to equal 1 over 5y times the derivative of that, which is 5. Okay, so this is going to turn out to be 1 over y, and then we're going to add the dy on there. And v, which means we integrate on this side, is just going to be y squared over 2. All you have to do is add 1 to the exponent, divide by your new exponent. So the pattern for this is going to be u times v minus the integral of v du. So u times v, u, which is y squared over 2, times v, natural log of 5y, minus v du. I'll change colors up here. So that's going to be 1 over y, the integral of 1 over y, times y squared over 2 dy. And if you'll notice in blue, this actually cleans itself up really nicely. I'm just going to come over here. We're going to look at it. That's going to be y squared over 2y dy. That's what we're looking at inside that integral. And the y's will cancel out. So part of this y cancels out with that y, and I'm left with this. And so when you integrate that, you wind up with just 1/2 times y squared over 2. Remember, you're going to add 1 to the exponent, which is now a 1, and divide by the new exponent. So my final answer on this is going to be y squared over 2 times the natural log of 5y minus this integral, which happens to be 1/4, or y squared over 4, plus c. So that last guy was a little bit tricky, but he wasn't too bad, and also that's using integration by parts, where 4 and 5 didn't necessarily require you to do that.